In this video, we will talk about Gauss representation of gamma function. In the earlier video, we also saw the Euler representation of gamma function, which was integral from 0 to infinity e to the power minus t to the power x plus 1 dt. And we also saw how this integral was equals to x minus 1 factorial, which was the gamma function. Now, in this video, we will show that this is also equals to gamma function. And in the next video, we are going to show we will see where stress represents the gamma function. Okay, so let's begin. First of all, we know that gamma function of x from the earlier video is equals to integral from 0 to infinity e to the power minus t to the power x minus 1 dt. Now we have e to the power t equals to 1 plus t by n to the power n, where n is going to infinity. Okay, so e to the power minus t will be limit n goes to infinity 1 minus t by n to the power n. We will replace it here. Integral from 0 to infinity 1 minus t by n to the power n, limit n goes to infinity, and then t to the power x minus 1 dt. Now we can take limit out of the integral, and then it will be limit n tends to infinity. Here infinity will be replaced by n, and then 1 minus t to the power t by n to the power n times t to the power x minus 1 dt. Now limit n tends to infinity. Now we can do integral. Yeah, so basically we take this as u and this as v. Okay, so we will have 1 minus t by n to the power n times t to the power x by x minus integral from 0 to n times 1 minus t by n to the power n minus 1, limit n tends to infinity 0 to n. Okay, this is derivative, and then we will have minus 1 by n, isn't it? Yeah, it is minus 1 by n, and then we will have t to the power x by x, t to the power x by x, and then dt. And now okay, so this is not integral. Okay, actually this is not integral because we are evaluating by integration by parts from 0 to infinity. So limit n goes to infinity, and this is actually n itself, not just infinity. This is n. Okay, so limit n goes to infinity, and at n this is 1 minus n by n, so that is just 0 minus at 0, this one is 0, so this is also 0, and minus now we can have this minus also comes out to make it plus, and n by nx. Okay, so this is kind of giving me trouble. Yeah, so this was, we were doing by parts, and here should have been plus, and it should have been something like n times integral from 0 to n times 1 minus t by n to the power n minus 1. Fine now. So n by nx, integral from 0 to n 1 minus t by n to the power n minus 1, and then t to the power x, and then dt. Okay, it's something like that we had earlier, but now x minus 1 has changed to x, and n has changed to 1 n minus 1. That's the difference. Others, others it's all looking good. Yeah. Okay, so let's proceed. So, and we get limit. If we do it again, if we do that again, now we have n by n minus x. If we do it again, we will just get x plus 1 in denominator and n minus 1 over here. So this will be n minus 1 in the front. Okay, so n minus 1 in the front and n in the denominator from here, and then x plus 1 from here. So this will be the result. An integral from 0 to 1 minus t by n to the power n minus 1 times t by x plus 1 dt. So I guess now we can make up, yeah, we can make up what will be the results. Okay. So basically this one is decreasing, and now when this goes to 0, so if we have n minus 2 over here, this is n minus 1, so now this should be n minus 2, I guess, isn't it? Because it should also decrease. Earlier it was, yeah, this should be n minus 2. Yeah, now it's fine. So it's limit n tends to infinity n minus 1. Now when it goes to 1, that is n minus 1. Okay, so when this product goes to 1, we will have here 1 less than the term that is 0, 1 minus t by n to the power 0, and here if we have 1, we have just x plus 1. Yeah, so if we have n minus 1, we will have t to the power x, yeah, x plus n minus 1, isn't it? Yeah, x plus n minus 1, that's good. And then dt. In denominator we have all of these were n for everything, also n over here, and we had x plus 1. So this was copied here, that means we have x plus n minus 1. Okay, so now that's fine, I guess. Now after this we just have to evaluate this integral. Limit n tends to infinity, this is n factorial, and from 1 to n, that means we have n to the power n over here, and x plus 1, this product up to x plus n minus 1. Yeah, and over here this integral will be t to the power x plus n by x plus n from 0 to n, and then limit n tends to infinity n factorial times, this will be t to the power this will be n to the power x plus n to the power x plus n only. This evaluates to n to the power x plus n by x plus n also. Okay, n to the power n x plus 1 up to x plus n. Now this is, now we can cancel this out and get limit n tends to infinity n to the power x, yeah, and also x over here, and the other stuffs can be written in forms of in the form of product. We can write it like this: a tau from k equals to 1 to n k by x plus k. Okay, so this k will give us 1 times 2 times up to n, that is n factorial, and x plus 1 x plus 2 up to x plus n will be given by this denominator, and the x is here in the front. So this is the Gauss representation of gamma function, and we have proved how it came. Yeah, so that was pretty interesting to see. And yeah, for for x, it should have been x over here, or else it should be s. This is a minor error, fine. Yeah, then yeah. Now let's just rewrite it. Gamma of x s equals to limit n tends to infinity n to the power s by s times product from k equals to 1 to infinity k by n plus k, and this is the famous Gauss representation of gamma function. Hope you enjoyed this proof. I look forward to seeing you again soon. Thanks for watching.